Welcome to our virtual class today. So we will be discussing the following. What is database transaction? States of transactions. What are ACID properties? Transaction types. Data manipulation language or DML. Data definition language or DDL. Data control language or DCL. And what is concurrency control? So let us first define what is a database transaction. A logical unit of processing in a database management system which entails one or more database access operation. In a nutshell, database transactions represent real-world events of any enterprise. All types of database access operation which are held between the beginning and end transaction statements are considered as a single logical transaction in database management system. During the transaction, the database is inconsistent. Only once the database is committed, the state is changed from one consistent state to another. Facts about database transaction. A transaction is a program unit whose execution may or may not change the contents of a database. The transaction concept in database management system is executed as a single unit. If the database operations do not update the database but only retrieve data, this type of transaction is called a read-only transaction. A successful transaction can change the database from one consistent state to another. Database management system transactions must be atomic, consistent, isolated, and durable. If the database were in an inconsistent state before a transaction, it would remain in the inconsistent state after the transaction. Why do you need concurrency in transactions? A database is a shared resource access. It is used by many users and processes concurrently. For example, the banking system, railway, and air reservation systems, stock market monitoring, supermarket inventory, and checkouts. Not managing concurrent access may create issues like hardware failure and system crashes, concurrent execution of the same transaction, deadlock, or slow performance. Here are the states of transaction. So we have active, partially committed, failed, committed, and aborted. So a transaction in a database can be in one of the following states. We have first active. In this state, the transaction is being executed. This is the initial state of every transaction. Next, we have the partially committed. When a transaction executes its final operation, it is said to be in a partially committed state. Next, we have failed. A transaction is said to be in a failed state if any of the checks made by the database recovery system fails. A failed transaction can no longer proceed further. Next, we have the aborted. If any of the checks fails and the transaction has reached a failed state, then the recovery manager rolls back all its write operations on the database to bring the database back to its original state, where it was prior to the execution of the transaction. Transactions in this state are called aborted. The database recovery module can select one of the two operations after a transaction aborts. It could either be restart the transaction or kill the transaction. Next, we have committed. If a transaction executes all its operations successfully, it is said to be committed. All its effects are now permanently established on the database system. We have here the state transition diagram for a database transaction. So we have the begin transaction, then active, end transaction, partially committed, committed, then we have failed or abort, and then we have the terminated. So let's study a state transition diagram that highlights how a transaction moves between these various states. Number one, once a transaction states execution, it becomes active. It can issue read or write operation. Number two, Once the read and write operations complete, the transactions becomes partially committed state. Number three, next, some recovery protocols need to ensure that a system failure will not result in an inability to record changes in the transaction permanently. If this check is a success, the transaction commits and enters into the committed state. Number four, if the check is a fail, the transaction goes to the failed state. Number five, if the transaction is aborted while it's in the active state, it goes to the failed state. The transaction should be rolled back to undo the effect of its write operations on the database. And number six, the terminated state refers to the transaction leaving the system. What are ACID properties? A transaction is a very small unit of a program and it may contain several low-level tasks. A transaction in a database system must contain atomicity, consistency, isolation, and durability. This is commonly known as ACID properties. This is in order to ensure accuracy, completeness, and data integrity. Let us define the various properties of acid. So we have the first one is atomicity. This property states that a transaction must be treated as an atomic unit. That is, either all of its operations are executed or none. There must be no state in a database where a transaction is left partially completed. States should be defined either before the execution of the transaction or after the execution, abortion, failure of the transaction. Next, we have the C or consistency. The database must remain in a consistent state after any transaction. No transaction should have any adverse effect on the data residing in the database. If the database was in a consistent state before the execution of a transaction, it must remain consistent after the execution of the transaction as well. Next, we have the I or isolation. In a database system where more than one transaction are being executed simultaneously and in parallel, the property of isolation states that all the transactions will be carried out and executed as if it is the only transaction in the system. No transaction will affect the existence of any other transaction. Next, we have the D or durability. The database should be durable enough to hold all its latest updates even if the system fails or restarts. If a transaction updates a chunk of data in a database and commits, then the database will hold and modify data. If a transaction commits but the system fails before the data could be written onto the disk, then that data will be updated once the system springs back into action. Next, we have the different transaction types. First is the data manipulation language or DML, a computer programming language used for adding or inserting, deleting, and modifying or updating data in a database. A DML is often a sub-language of a broader database language such as SQL, with the DML comprising some of the operators in the language. Read-only selecting of data is sometimes distinguished as being part of a separate data query language or DQL, but it is closely related and sometimes also considered a component of a DML. Some operators may perform both selecting or reading and writing. In SQL, the data manipulation language comprises the SQL data change statements, which modify stored data but not the schema or database objects. Manipulation of persistent database objects, example tables or stored procedures, via the SQL schema statements rather than the data stored within them, is considered to be part of a separate data definition language or DDL. In SQL, these two categories are similar in their detailed syntax, data types, and expression, but distinct in their overall function. The SQL data change statements are a subset of the SQL data statements. This also contains the select query statement, which strictly speaking is part of the DQL, not the DML. In common practice, though, this distinction is not made and select is widely considered to be part of DML. So the DML consists of all SQL data statements, not only the SQL data change statements. The select into form combines both selection and manipulation, and thus is strictly considered to be DML because it manipulates or modifies data. In the SQL DML statements, each clause in a statement should begin on a new line. The beginning of each clause should line up with the beginning of other clauses. If a clause has several parts, they should appear on separate lines and be indented under the start of the clause to show the relationship. Uppercase letters are used to represent reserved words, and lowercase letters are used to represent user-defined words. Data manipulation languages have their functional capability organized by the initial word in a statement, which is almost always a verb. In the case of SQL, these verbs are select from where, select into, insert into values, update set where, delete from where. So these are some of the examples of data manipulation languages. So we have insert, which is used to insert data in a table. Next, we have update. It's used to update or modify existing data within a table. And we have delete, which is used to delete records from a database table. Next, transaction type is data definition language or DDL. A syntax for creating and modifying database objects such as tables, indices, and users. DDL statements are similar to a computer programming language for defining data structures, especially database schemas. Common examples of DDL statements include create, alter, and drop. Many data description languages use a declarative syntax to define columns and data types. Structured query language, or SQL, however, uses a collection of imperative verbs whose effect is to modify the schema of the database by adding, changing, or deleting definitions of tables or other elements. So these statements can be freely mixed with other SQL statements, making the DDL not a separate language. It consists of the SQL commands that can be used to define the database schema. It simply deals with descriptions of the database schema and is used to create and modify the structure of database objects in the database. Examples of DDL commands are as follows. We have create. This is used to create the database or its objects like table, index, function, views, store procedure, and triggers. Next, we have drop, which is used to delete objects from the database. Next, we have alter. It is used to alter the structure of the database. Next, we have truncate. This is used to remove all records from a table, including all spaces allocated for the records are removed. Next, we have comment. This is used to add comments to the data dictionary. And we have rename, which is used to rename an object existing in the database. Next transaction type is data control language or DCL. It is used to control the access of the data which is stored in the database. The DCL becomes very useful in the case where the database is exposed to multiple users who might update or make changes to the database, which in turn might create many issues. These are some data control language needs we need to be aware of. It is used to control the privileges given to the users in a database. It prevents the other users from making changes or updates to the database by providing access or removing them to the users. It is to be noted that not all the users of a database have all the privileges to carry out all the operations concerning a database. For example, not all the users can have permission to execute all the data definition language or data manipulation language commands. It is the responsibility of the database owner or the administrator to provide privileges to the different users according to their roles or the business need. So, the DCL provides the necessary means to maintain the database effectively so that no other users can make any changes that do not concern their role or might impact the security of the database. Examples of DCL commands are grant and revoke. So grant give users access privileges to databases, while revoke withdraw users access privileges given by using the grant command. Now let's proceed with concurrency control. Concurrency control is the procedure in database management system for managing simultaneous operations without conflicting with each other. Concurrent access is quite easy if all users are just reading data. There is no way they can interfere with one another. Though, for any practical database, would have a mix of reading and write operations, and hence the concurrency is a challenge. Concurrency control is used to address such conflicts, which mostly occur with a multi-user system. It helps you to make sure that database transactions are performed concurrently without violating the data integrity of respective databases. Potential problems of concurrency. So we have loss updates occur when multiple transactions select the same raw and update the raw based on the value selected. Next problem, we have uncommitted dependency. Issues occur when the second transaction selects a row which is updated by another transaction, also known as dirty read. Next, we have the non-repeatable read. Occurs when a second transaction is trying to access the same row several times and reads different data each time. Next, we have the incorrect summary. Issue occurs when one transaction takes summary over the value of all the instances of a repeated data item. And the second transaction update few instances of that specific data item. In that situation, the resulting summary does not reflect a correct result. Why use concurrency control? So these are the reasons for using concurrency control methods in database management system. So to apply isolation through mutual exclusion between conflicting transactions, to resolve read-write and write-write conflict issues, to preserve database consistency through constantly preserving execution obstructions. The system needs to control the interaction among the concurrent transactions. This control is achieved using concurrent control schemes. Concurrency control helps to ensure serializability. So example, assume the two people who go to electronic kiosk at the same time to buy a movie ticket for the same movie and the same show time. However, there is only one seat left in for the movie show in that particular theater. Without concurrency control, it is possible that both moviegoers will end up purchasing a ticket. However, concurrency control method does not allow this to happen. Both moviegoers can still access information written in the movie sitting database. But concurrency control only provides a ticket to the buyer who has completed the transaction process first. So now let's review what we have discussed today. So first, we define what is a database transaction. Next, the various facts about database transaction. Why do we need concurrency in transactions? And then the various states of transactions like active, partially committed, failed, aborted, and committed. Next, we also provided a state transition diagram for a database transaction. Next, we have defined and discussed what are the acid properties, which are atomicity, consistency, isolation, and durability. Then we also define and discuss the various transaction types like data manipulation language or DML. So a DML is used for adding or inserting, deleting, and modifying or updating data in a database. So example of which are insert, update, and delete. Then we also defined what is data definition language. So it is a syntax for creating and modifying database objects such as tables, indices, and users. Example of DDL commands are create, drop, alter, truncate, comment, and rename. Next, we have the data control language, which is used to control the access of the data that is stored in the database. Example of DCL commands are grant and revoke. Next, we also defined what is concurrency control. The various potential problems of concurrency, such as lost updates, uncommitted dependency, non-repeatable read, incorrect summary. Then the reasons for using concurrency control methods in database management system. And we also provided an example of concurrency control.